Chapter 1, Lesson 9, Comparing Numbers that are in Scientific Notation. When comparing two numbers in scientific notation, the number with the larger exponent is the larger number. So when you're comparing them, the larger the exponent, the larger the number. So the first example, 8.5 times 10 to the third. So we're comparing the exponents, and 10 to the fourth is the larger number. So this sentence would read 8.5 times 10 to the third is actually less than 2.4 times 10 to the fourth. Again, this number is less than this number because the larger exponent tells us that. Okay? And when dealing with negative exponents, okay, we actually want the smaller of the, that looks smaller, because -3 is actually a bigger exponent than -4, because -3 is closer to 0. So 2.56 times 10 to the -3rd power is actually greater than 2.89 times 10 to the -4th power, because if you were to look at it, this would move the decimal point 3 places, so 0.00256 is compared to 0.000289. So you can see that by the third number, it is larger, so it's greater than. Okay. Which has the greater mass? The Titanic, which is 5.2 times 10 to the 7th, or the Great Pyramid of Giza, 6 times 10 to the 9th. So by comparing the exponents, 10 to the 7th versus 10 to the 9th, that the pyramid has the greater mass. Earth's moon, 7.3 times 10 to the 22nd, versus Titan, one of Saturn's moons, which is 1.3 times 10 to the 23rd. Titan has the greater mass because the 23rd power is greater than the 22nd power. And lastly, HIV virus is 1.1 times 10 to the -18th, and E. coli is 1.3 times 10 to the -16th. So which one of these viruses has the greater mass? That would be E. coli. Because when you're dealing with negative numbers, the closer the number is to 0, the bigger the number is. If two numbers written in scientific notation have the same exponent, then just compare the numbers that are in front of the times 10 to determine the larger number. So as you can see, 10 to the 3rd and 10 to the 3rd. So then we just want to look and compare the numbers that are in front of the times 10 so that we can make our comparison. So in this case, 9.3 is in fact greater than 8.52, and 4.7 is also greater than 2.1. Okay, down here, we have this table of the years and the number of cars that were sold in that year. So the first question, in which year were the most cars sold? Well, the most cars would be the highest exponent, so 10 to the 7th. 10 to the 7th would be definitely 1, and 10 to the 7th. So now we need to compare 2.4 to 1.8. So the correct answer would in fact be 1980 was the year that the most cars were sold. Okay. In which year were the least number of cars sold? So we want, obviously, the smaller exponent matched up with the smaller whole number in front. So in fact, it would be 1990 that the least amount of cars were sold. And then the last question, how many more cars were sold in 2000 than in 1990? The hint, you want to convert them to standard form first. So 8.9 times 10 to the 6th minus 3.8 times 10 to the 6th. Converting them to standard form would be 8,900,000 minus 3,800,000. And when you subtract them, you get 5,100,000 more cars. And for this question, you probably want to leave it more in standard form because they're talking about the number of cars that were sold. So you're not really going to put the number of cars sold in scientific notation to answer a question. Now we're going to talk about how many times greater. Okay, a lot of times when you look on, especially on the state test or things like that, they're going to ask you a question 9 times out of 10, how many times greater or how many times bigger is something than something else? Okay, and our formula that we're going to use is going to simply, whenever we're asked this question, we're just going to take the bigger number and divide it by the smaller number. Okay? So once again, the bigger number divided by the smaller number. So going back to our Titanic versus the Pyramid of Giza. So we know that Giza was the bigger number. Okay? So how many times bigger or greater is the Pyramid of Giza versus the Titanic? Well, we would simply say 6 times 10 to the 9th divided by 5.2 times 10 to the 7th. If we were to convert that into standard form, it would be 6 billion divided by 52 million. And when we divide that out, we get 115.3 846,154. And if they did for whatever, so that would be your answer as far as how many times greater. In the case, if they did want you to convert that into scientific notation, you could say 1.15 3846154 times 10 to the 9th. Either one of these would be acceptable answers based on if the question was specific or not. And the next example, the Earth's moon versus Titan, one of Saturn's moons. We know that Titan was the bigger number. Now, for the sake of space, okay, I'm not going to write it out in scientific notation with 23 zeros divided by 22 zeros. I'm just going to write it in as 1.3 times 10 to the 23rd divided by 7.3 times 10 to the 22nd power. And your calculator will be your friend when it comes to this. Make sure that it's in scientific notation. And you simply make sure when you're punching it into the calculator that you put parentheses around each one of the number, the whole number. And when you punch that in, you will get the answer as to how many times larger Titan is than Earth's moon. And that number comes out to be 1.78082192 times bigger. So you can tell that it's quite large. Titan is quite large compared to Earth's moon, almost, if you were to round up, 1.8 times larger, just about twice the size. Good. Okay, and then one more with a table and the years and the number of cars sold. The number of cars sold in 2010 was how many times greater than in 1990? And again, remember, we want the big divided by the small number. So in 2010, it was 1.8 times 10 to the 7th. And that is the bigger number because the exponent tells us that. So 1.8 times 10 to the 7th divided by 3.8 times 10 to the 6th. Okay, and once again, if you put this into your calculator in scientific notation, make sure that you put parentheses around the entire number so it groups the whole number together, and then hit equals, and it comes out to be 4.736842105. Okay, so, and if we were to round this, we would say approximately 4.7 times more. Okay, so again, we take our larger number of cars sold in 2010 and we divide it by our smaller number, which was in 1990. Convert it, and if they want, they might ask you to round, they might not, but if you're talking about times more, I don't think you need to go into that great a detail, just round it to the nearest tenths. So it's 4.7 times more cars in 2010 than in 1990. All right, so we've come to our exit ticket for this lesson. Once again, I ask that you please complete your exit ticket and bring it with you to class next time we meet so that we can go over it and make sure that we understand everything that we learned in this lesson. And as always, thank you for watching our video and thank you for your participation, and we will see you next time.